In order for us to solve problems in Botswana, we need our developers to stand up, move past the excuses and the crybabyism, and build solutions that Botswana across the country will be able to use, because Botswana will now start to have access across the nation. The revolution that we're going to see due to AI is going to fundamentally change how everything happens and the world as we see. The goal should be very simple. That particular technology should either make your business better, should be able to make you cheaper, should be able to make you faster. If it's not doing any one of these three things, then it's a useless technology. It's not just not building alone. We might build, but if it doesn't solve the problem of a Botswana at home, then they will not use it. The most important thing kids must be taught in school today, how to solve problems. But it doesn't really help that the person who gets the highest grades, especially like at a high school and primary school level, is the person who can cram the most.
Today we have a special guest, Mr. Tavonga Muchuchuti of Xavier, Africa. So ladies and gentlemen, help me welcome to the show this man. How you doing, man? What is up, everybody? Welcome to Deep Dive Sessions. My name is Mpomo Tauria. Thank you for stopping by. Today we have a special guest, Mr. Tavonga Muchuchuti of Xavier, Africa. So ladies and gentlemen, help me welcome to the show this man. I've been following your journey. I think the first time I saw you was as valedictorian of BAC 2019. I mean, that deserves a round of applause. Obviously, we talked about it before we started. Today we're talking about AI, man. This is just a very, it's the thing that was throwing around. Everyone just saying AI, force IR, all that. But where I want us to start is, can you demystify for us the difference between AI and machine learning?
Yeah. So I think it's worth understanding the way that these things are built before anything else. So one of the key things that I see people making the mistake of is assuming that these AI systems are built in some special kind of mystic way. In essence, AI as a field is the pursuit of trying to get machines that can be able to perform tasks, cognitive tasks, that human beings can. That's as simple as it can be. And the idea really from the 1950s, when Alan Turing was coming up with the concept and initially putting together the building blocks, the idea was, right now, machines can be able to process large amounts of data and large amounts of information. Thanks. So how can we be able to actually train a machine to be able to have the cognitive ability to think through matters and be able to make decisions through decision pathways, just like a human being would.
Using data to make decisions.
No, before we get there, at this point, the abstract concept was about allowing a machine to be able to understand what's going on and then be able to make a decision. So the next part now is artificial intelligence is sort of the mother concept of all of this. And AI really can be pretty much anything. As long as a machine is intelligent, we can call it an artificial intelligent machine. But now, over the years, as research was going on and as more and more work was being done in this field, then we started to see the emergence of different concepts coming together. So under the mother body of artificial intelligence, we're going to have machine learning on one side. We're going to have what we call deep learning on the other side. So machine learning, in fact, is whereby we use large amounts of data to be able to actually find patterns within that data that can tell us about how to move with the phenomena that are on the table. So say, for example, you want to understand and want to enable a machine to be able to tell the difference between a dog and a cat. What you will do under machine learning is you will take 100,000 pictures of a dog, 100,000 pictures of a cat, and then you will load them into what we call a model. This model now will try and find what similarities are between all the dogs. What similarities and features are in all the cats. And in simple fact, we'll be able now to differentiate when you bring a new picture to say, this is a dog and this is a cat. That's the basic idea of machine learning. On the other side now, we have deep learning. So now people then found out that, look, simply training these things with very few epochs is not working. It's not getting us to a point whereby a machine, for example, can be able to differentiate whether a person has a disease in an X-ray image, or whether somebody can be able, a machine can be able to win a chess match, for example. So deep learning now then became trying to simulate the way that the human brain works to be able to allow the machine to make decisions. So if you look at what how the brain works, it works through what we call neural networks. Neural networks, basically, it will take a small piece of information and then through several sets of sub-decisions will then go on to make one final decision. I like to give a very simple example. Say, for example, somebody asks you to say, I want you to come to a party tomorrow morning, or tomorrow evening, sorry. When they say, I want you to come to a party tomorrow evening, this is not a decision that you can make with only one factor. It's a multi-factor decision.
Thanks.
Number one, you have to ask yourself, who's going to be there at the party? Is it people who are interesting? Is it people who are boring? Same thing. Okay, do I have the transport to be able to actually go there?
And come back.
And come back. Number three, do I have the time? Do I have the money to actually go and spend there? In fact, am I interested at all? But although you have these 5 decisions that you need to make here, all these different decisions have different weight to the total decision. So for example, there might be interesting people who are there at the party that you want to interact with, but maybe you don't have money. So the fact that you don't have money has more bearing or more weight than the fact that they're interesting people who are there. So what neural networks now start to do is they take all these sub-decisions and then now from those sub-decisions go on to make a final decision to say, based on all these neurals or this network, this is what the final answer or response should be based on that. But again, this is working through sometimes millions of neurons, which is something like what ChatGPT is and how it works. But we'll get into that later.
Lovely. I think we can end here and go home.
Go home.
And go home. No, that was good. I like the way you articulated it very well. Actually, let's get into that because I was using just this 2 hours ago. I was using ChatGPT and I thought, how is this? Where are we extracting all this data from and all these subsets? But you put it very well. But let's go into it a little bit deeper because this is a tool that we're using, and I'm sure you know the stats of when it was rolled out and how many people started using it immediately because of just it makes life just 10 times much easier.
Yeah.
How were they able to make something that powerful? Because also that they keep making it better and better and better and better, and it keeps getting to know more and more of who you are, and it's making it even more targeted. Even in what it's telling you, it makes it even more targeted. I mean, I wrote a poem for a 43-year-old male who was turning on a certain birthday, who likes brown, who likes all these kind of things with ChatGPT.
Yeah.
So talk to me about that.
Okay, so how much time do we have? I geek out when I talk about some of these things because it's some of the stuff that we've looked at as theory for years. So again, right, when you look at my background, for example, I've been in this space for the better part of the last 5 to 6 years. And I'm actually a scholar as well within this current field. I'm doing my PhD in artificial intelligence at the moment.
Lovely.
And this is our stuff, So the one thing that you do when you look at, when you look at a tool like ChatGPT is you realize that it's not all that smart. We as human beings, a lot of what we do is just really not all that difficult. I'll give you an example, an understanding. ChatGPT works on what we call the transformer model. The transformer model, please follow me. And if you feel like I'm losing you, just lift your hand.
Yeah, just raise your hand.
But I'm going to make sure that I take us step by step. It uses what we call a transformer model. The transformer model was released by Google in one of the most exciting papers of all time, academic papers of all time, which was called Attention is All You Need in 2016. And the idea behind that particular model was that some of the techniques and methods that we're currently using to create, language understanding models were not the best possible way to do it. But rather, this transformer model would use what we call positional encoding. And in essence, the goal of positional encoding would be to guess what the next word should be. Effectively, what we call autocomplete. So when you ask ChatGPT today, write me a poem about Tavonga, who likes XYZ, who likes AI, or who likes basketball and LeBron James. Oh, I'm a LeBron fan, by the way.
Me too, man.
Hallelujah.
Me too.
There we go. Who likes LeBron James and who... I see these headers in the building.
Yeah.
Who likes LeBron James, who likes, AI and is, likes the outdoors, right? What it then does is with these different sentences and phrases that you've brought in, it tries to guess what that profile, right, of wording would have next just after it. So now, this is where those neural networks start to come in. So now it will be, if the positional encoding is saying, a guy that likes basketball, right, and likes this particular thing, and like this particular thing, right, where do they stand in the positional encode? So then, from there now, when a sentence is generated, it's a sentence that's aligned to what other people have most probably said and the order of the words when that particular thing was said. I don't know if I...
So it's a pattern that's been generated before.
Yes, more than anything else, right? It's all about the position of the words. And that's pretty much what language is all about, if you think about it. When we're dealing with language, right? When you're constructing a sentence, it's a matter of saying, for example, I want to say, the phone is there. I will say, the phone is there. And the general order of the words, when I say, where is the phone? The highest probability is that it's going to say, the phone is there. Or if I ask, where was the phone yesterday? The phone was at X location yesterday. So it's basically essentially following the patterns of language. And that's pretty much how, ChatGPT works, at least, today.
Lovely. Now, in the world of AI right now, you have offices in Gabs and Johannesburg. Talk to me about adoption. What are, especially right now, because this is your space, what are the industries or sectors in a business sense that have adopted AI quickly? That see that, okay, this is where the world is going. I need to do this now to eliminate, operational efficiencies, what you guys do a lot. Talk to me about that.
So one thing that I will start with and I'll always lead with is that whenever a new technology is adopted, the goal should be very simple. That particular technology should either make your business better, should be able to make you cheaper, it should be able to make you faster.
Yeah.
If it's not doing any one of these three things, then it's a useless technology. And you see a lot of organizations waste so much resources because they fail to answer the fundamental questions of how does this piece of software, how does this piece of technology make us better, make us cheaper, make us faster? And so one of the biggest things that has come into the phenomena in the market now is when I'm selling our services, I'm no longer selling to say to a company, this is AI, this is what? Because executives don't care about that.
Yeah, they care about the results.
At the end of the day, any really smart executive cares about how much cost am I going to have, how much revenue am I going to make, and what bottom line am I going to have? And if a piece of technology justifies and has evidence that it can actually go on and improve those outcomes, then it will be adopted. Currently, we've got anchor industries that we currently mostly work in. We work with governments. So we've got several governments across the continent where we're deploying some of these AI systems around especially communication and unifying communications. Number two, we've got mines. So there's a lot of inefficiencies that are existent in a lot of mines around the world.
Yeah.
And they understand the need to improve those inefficiencies, to make the mines more efficient and ultimately to improve productivity. Number three, financial services. Again, financial services is a lot of data that is around that is needed to make decisions. You can imagine an investment manager has hundreds of thousands of potential investments they can make on a particular day. How do they decide what the best investment to try and look further at today, should be? And AI really, really helps in that kind of space. So a lot of the work that we're doing today is really in those three industries. And obviously we've got other sub-industries that now are starting to emerge, over time, where we're dealing with, several other organizations outside of our core, industries.
Lovely, lovely. Talk to me about government. I know you've worked with government a lot. Talk to me about some of the ways you've worked with government, and even just on a policy level. Are there any policies right now that speak to AI in Botswana that can be able to, enhance and push this forward?
Yeah. So one of the things that I have really enjoyed over the years is that I have enjoyed a great working relationship with quite a number of African governments, actually. So, here in Botswana, in South Africa, in Zimbabwe, Nigeria, Egypt, we've had some really, really great relationships with everyone, because the big thing that is happening across the world now and across Africa is there's this Africa rising that's not coming necessarily from the resources that we have, but that is stemming from the high quality of leaders that we're starting to have across the continent. And look, the truth is that things are not going to change overnight, but it's through actions of very decisive and very hardworking leaders that really want to see change. And we're seeing a big wave of that going on across the continent.
Intentionality.
And that intentionality, right, is what, a government department will come and say, look, we know nothing about this AI thing. Let's call in all the people who've built work in this field before. We have evidence of exceptionality in this space, and let them come and tell us what we should do. Let them come and sit here with us and say, look, guys, there's a new space. How do we regulate it? And the Hotla system, for example, which was one of my favorite, models that we have in Botswana, where all the stakeholders sit down, and discuss, what the implications and what the potential regulations could be, is really, really where it's at. So whilst right now we don't have, rigid regulations that are on the table, we expect that in, between first and second quarter next year, we should be having a bunch of digitization, related regulations coming in on the ground, to sort of give us a framework as to how we will digitize and how we will move. We've already seen the Data Protection Act already, that has come in of 2020, and it's going to be enforced next year as well. And these are all, components of artificial intelligence, and we'll start to see, these roll out more and more. And because AI is a really new field, regulators are not trying to overregulate, because if you overregulate too early, you will stifle innovation.
True.
And if you regulate too late, there'll be too many scams on the table already, and people are exploited. So regulators around the world are really trying to get that mix right. And, that's really where we are currently.
Yeah. And it's just it's a learn as you go type of thing.
That's it.
Because like you were saying, this technology is ever changing. Yeah. So you just have to keep adapting to it as you move forward. But to that, I read the 2023 to 2025 transitional plan. In there, the word digital is mentioned 65 times. I think on a government level, the government has done a lot in terms of digitalization. Yeah. It is a lot. I think maybe the gap is on the ground. Yeah. On the ground, it's quite, there's a lot that needs to be done. There's a lot that needs, but on a government, on a macro level, because there's so many, even policies right now, there's so many policies. I could name at least 5. Even when you look at BOCRA, the data and everything, there's tier 2, tier 3. I mean, it's crazy. But where I wanted us to go is talk to me about the practicality of building this technology. Yeah. Because I think we also need to have the infrastructure in place to be able to build that. Yeah. And I think this is something that we have lacked as Africa, having the infrastructure to allow us to build this, to be able to solve even the unique African problems that we have. Where are we on that? And how can we be able to move in that direction?
So, if only you knew, right? Botswana, when it comes to infrastructure, digital infrastructure, in terms of readiness for digitization, from an infrastructure level, majority of Botswana, in fact, in the 90 percentile, have access to internet. And when I say have access to internet, it means that the pipes have been laid, the fiber has been laid, the satellites, have been deployed across the country to make sure that we have one of the highest internet penetration rates in the world. Data cost is still, a big factor, because we're streaming our data from all the way in the US for majority of our content. So obviously there's a lot of work that's going on there. Yeah. But in terms of from a reach perspective, there's a lot of work that's been put there. Yeah. Now the biggest challenge is that whilst the network is there, and whilst, for example, clinics around the country now have access to internet, schools around the country now, there's a plan to have all of them have the internet. I think majority of them now have the internet. Hotels, majority of the hotels now have the internet as well. Now, the accessibility part, which is the role of government, is done. Which is the role of big telco, is done. In Botswana, we have some of the most sophisticated data centers in the world. The Tier 3, with one of the telcos, and the Tier 2, the other telco. These are massive projects.
I mean, we have Tier 3. That is huge.
And because of that, right, you look and say, look, the infrastructure has been built. Now, this is just facilitating for people to be able to stream overseas content. So where are our developers here in Botswana? Where in order for us to solve problems in Botswana, we need our developers to stand up, move past the excuses and the crybabyism, and build solutions that Botswana across the country will be able to use, because Botswana will now start to have access across the nation. And Botswana are not dumb people. They are people who have problems. They are people who want their problems to be solved. And a big part of it now is building those solutions. And again, then, we then also have, of course, the adoption issue. Who taught you how to use ChatGPT?
Myself.
Nobody taught you how to use ChatGPT because it was intensely useful. And it was simple enough to use. And that's the challenge that now has to go back now to engineers and developers like, our Xavier Africas. We now have the challenge to build solutions that solve a problem. You had a problem. You need to write, a particular body of text. You need to write an email. You have all this drudgery you have to do. You need something to use. You use ChatGPT. It solved your problem. Number two, it was very simple to use. Whilst what's going on in the background is very complicated, it was very simple to use. And on the other hand as well, you have the infrastructure and the access. So all those building blocks have now been put together, and now it's up to us to now build solutions that are simple enough for the people to use, but yet they solve the problems. And I believe that once we build that way, with that in mind, people will use the solutions.
And you're right, we actually have the people. I have data on BDIH recorded about 2,000 and something developers in Botswana in terms of the hackathons that have run. Just the hackathons that they have run and the registered developers and the hackathons that have been run. 2,000 and something engineers, developers who were able to do that. And even like you were saying, mobile telephony, like the penetration of the mobile phone is over 100% in Botswana. And so you're spot on with that. So the issue is we're not building these things.
It's not just not building alone. We might build, but if it doesn't solve the problem of a Botswana at home, then they will not use it. If the solution is not simple, does not solve the problem that they have fundamentally, and they cannot get access to it, then at the end of the day, they're not going to use it. So we need to tick each and every single one of these boxes, and then we will have adoption. I mean, nobody taught us how to use Facebook in this country, but one of the fastest, one of the biggest Facebook countries in the world.
That's
from
right.
from a per capita rate. So at the end of the day, if we solve problems, the customers will come.
Customers will come. So it's not even about how good we think our solution is.
Nope.
It has to be usable to the customer.
That's it.
Do you think we have a fear of adoption in a way? Like, are we on a general, you know that bell curve? Where there's early adopters and then blah, 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 blah. As a country, where do you think we lie there?
Look, that's a very, very difficult question, right? Or rather easy question, largely because there's no country in the world that we can say, oh, these guys are early adopters. Or they're what you call innovators just before the early adopters are coming in. Really, at the end of the day, depending on what industry that we're currently dealing with, I remember when BeSafe came into the market during the COVID-19 pandemic, right? Everybody needed a permit to go somewhere. That level of necessity meant that you had to go and get that app for you to be able to go outside. So that necessity made adoption tick up. Same thing when you look at some other solutions that are in the market. You look at solutions like, for example, when you look at the adoption of a Facebook, for example, in the country. You knew that your friends are on Facebook.
Yeah.
But you're not there now, you're feeling left out. The need to be there made you an adopter. A lot of us, I remember I joined Facebook when I was standard 5. A lot of people, when they were young, when they were in high school, some people, when they're in their 30s, their 40s, to find their friends. And obviously, because by the way the bell curve works, some people are going to adopt this much earlier than other people will. Okay. But at the end of the day, is it solving a problem? If a problem is being solved and the problem is painful enough, people will not mind using a product that sucks at the beginning if it solves their problem.
I want us to talk about Samantha, but before, let's go into. I watched an interview. It was with Mr. Strive Masiwa and another guy, another gentleman. Yeah. Thank you. So, and he described AI as like the magnitude of it, likened it to the Industrial Revolution that happened long back that time. Right. And that was one of the biggest that hit the world. So could you, in your opinion, because you've been in the space, you're deep in it for many, many years, describe AI and its magnitude? Because I think that we may not know the magnitude of AI that's going to have on our lives and just on everything that we're going to be doing. So just describe it for us.
Look, I think every time I hear a lot of AI discourse, there's a lot of over-optimism and also a lot of under-appreciation of what it's capable of. Right? Largely, AI systems that we have that exist today are highly likely not going to take your job for a lot of jobs out there. And that's one big fact that I think people haven't really understood yet. Because the thing is that where we are with AI right now is that it's able to do certain tasks really, really well. So for example, if you're like a social media manager, right? It's able to generate maybe 10 pieces of copy much faster than you could be able to do.
Yeah.
But it's not going to be as good as the best copywriter in the office. Same thing when you look at, for example, in that same social media thing, maybe it can analyze the data for you. But in terms of coming up with actionable insights that will be able to engage and push virality, it's not going to be better than the guy in the office who comes up with the creative ideas that can make that happen. Largely, on a general perspective. For now, look, we're talking about AI systems that we have today. Because largely what we have today is what we call two parts of AI. There's what we call general AI or artificial general intelligence, which is what everyone is trying to pursue right now, where it's sort of this all-knowing machine that understands how to solve all the problems across the world, that is able to comprehend and sort of be an Einstein of sort. On the other side, we have what we call narrow AI, which is what, for example, on your Netflix, it's going to recommend the best possible movie that you're going to watch or something like that. Yeah. Because it's narrow, in its nature. So a lot of what we're seeing in AI right now is that it's a lot of narrow applications that solve one thing and they solve it really, really well. Like, for example, AI is able to find child pornography much faster and a bigger scale than the human evaluators are able to, for example. Whilst now on the more general intelligence stuff, there's no real AI systems that have been able to touch that. Even the most state-of-the-art like GPT-4. So with that in mind, right, the thing is that the revolution that we're going to see due to AI is going to fundamentally change how everything happens and the world as we see it. Right now with just the narrow AI that we're looking at, for example, where we're helping, some hospitals in remote areas to be able to screen patients for cervical cancer much faster using just images. Now, that kind of exponential, rate of capability to be able to do things, now, when you now couple it with general intelligence, we might actually see one of the biggest displacements of all time in terms of jobs and roles of people in society, or it might just again be a fad in how it all ends up. And it just means that maybe people will be repositioned from the work they're currently doing into other things. Because right now, a lot of what AI can do well is repetitive stuff, is stuff that is repeatable, that is routine, that is the same. But when it comes to the more nuanced stuff, it's still really struggling. And right now, I wouldn't say be worried about your job. But you've got to be able to make sure that you can utilize those AI solutions to make yourself accelerate at your job.
Yeah, this is what I always like. Even the conversation I have with people on the street is that just find out how you can best use AI because it's a tool, tool. Use it as a tool. Because also what I think about is AI is also combining different technologies onto it. Like there was one way a student used AI connected to 3D printing, had the whole essay written for them. Those kind of things where it's taking different technologies and building on top of it. This is where I think a lot of the power is when it takes and builds on technology, because I don't think, at least in my own limited view, I've never seen something happen to that magnitude. So even when you talk about the internet, when it came in the 90s, and then it changed everything of how we do today, and then now AI is building from the internet, got all these things. This is where I think that AI is really going to have that, because it builds on and it just gets better and better and better and better and better. Yeah. So let's talk about Samantha. What are you guys doing there? And how were you able to actually develop this and why?
Yeah, so look, one of the key challenges that I think I mentioned earlier on in the conversation was one of the key issues that almost every organization that I talk to has when it comes to investing in AI is the high level of risk from a financial perspective and a time-wasting perspective. Because like I said earlier on, for you to be able to build a meaningful AI program within your organization, one that is robust and secure and scalable, you need to spend some pretty bucks. And because of that, that's been an inhibitor for a lot of organizations across the world, because they're saying, look, we don't have the R&D budget, for something that you can try out and fail and so on. And so, that's why it's been limited to very few organizations across the world that have been able to invest in that and have that capability. So for us, as Xavier Africa, we looked here at home and we said, look, we might as well build engines of our own, that we take money that we've made over the years and then use that to build our own foundational models. That way, we're removing a lot of the risk elements from that, and then now allow organizations to be able to build on a foundation that's already been put together. And then so right now, for example, we've got 3 such engines that we've built. We've got the first engine, which is the Samantha engine, which is a conversational engine. The second one is the Super Intern engine, which is an automation engine. And the third one is the Vision X model, which is the vision engine. So the Samantha engine is currently optimized for call centers. So the idea around call centers is that there's just way too many calls that are coming in for call centers for an organization to be able to hire enough people who can answer all those calls while still being profitable. Everyone is frustrated by the customer experience that they're getting in call centers. And for other industries even, not being able to call their customers and talk to their customers is losing them revenue on a daily basis. So what we did when we built Samantha is we optimized Samantha to be able to be a conversational engine that organizations could build their own autonomous call centers on. So an organization would come and plug in. So for example, right now we've got insurance companies and telecommunications companies that just plug into Samantha. And if a customer has some questions about their policy or some issues around their policy, they call Samantha and they're able to have a full conversation with Samantha about I want to claim, can I do that? And then Samantha is able to use her intelligence and connect to the information in the business to be able to process that claim on behalf of, the customer, doing sort of what the human would typically do. But usually, in a call center, the performance at 8 a.m. is different from the performance at 5 p.m. You're tired and the drudgery is there. So it's able to really handle, about almost 1,000 simultaneous calls at any given point in time, and is really driving, quite a number of organizations in that area. So currently we've got clients in telco, clients in insurance, clients also starting to come up now in mining as well, that are really leveraging that technology to be able to actually build their own autonomous call centers for internal customers and also external customers. The second one, like I said, is the Super Intern. The idea behind the Super Intern is actually where my PhD research is. I still don't believe that a lot of the jobs that we do as human beings, machines or AI has gotten to a point where they can adequately take them. But I kind of believe that if you can take an adequately trained AI model and then teach it things the way you teach an intern, as patiently as you teach an intern, it can be able to do quite a number of things that a human intern would be able to do in a typical day. So that's what we've trained that automation engine to be able to do. So for example, to be able to create different types of reports from internal business information, to be able to do low-level, to mid-level reports, to be able to, do some diagnosis and diagnostics at some stage, within an organization's process flows, that kind of stuff it does, and it does very well. And we found quite a number of organizations, especially in mining, that have been taking up on that particular technology, because there's really too much work and too little people to be able to do it. The third one is Vision X, probably my favorite one, but the one that is still a little bit behind. The Vision X, the idea behind Vision X is that to be able to give AI some eyes, right? So what we've done over the years is we've got different domains of information and knowledge that we're specializing in. So currently, where a lot of the interest has been around medical imagery, because we have too few specialists that are there in hospitals across Africa. And because of that, what we're doing is we don't do diagnosis or diagnostics on a patient. What we just do is we help specialists to be able to prioritize patients to see. So what we're doing is using Vision X. For example, right now we've got a big pilot project that we're doing in the SADC region, whereby we're doing for cervical cancer. So we've got millions of pictures of cervical cancer patients in different stages. And then what we do is in remote areas, somebody's able to just simply take a picture, and then it's able to calculate the probability that this patient might have something adverse that's happening with them. And then we're able to take that and then forward it and prioritize that person over someone who might have a lower likelihood when the specialist is going through that. That way, we're able to save more lives and much faster. And that's the kind of work that we're doing across those foundational models we built.
Lovely, lovely, lovely. I think actually that deserves a round of applause, because it's solving a lot of problems and it's making it so quickly.
Yeah.
So that is amazing, man. Talk to me now about the education pool in terms of AI.
Yeah.
I think this is where we also need to go deep into, especially for the younger generation, educating them on AI so that they're able to be well equipped and start this on an early generation. Is there any work that you're thinking about in terms of that area?
Yeah, look, I think we've got a very interesting academy that we built over the years. It's called the Xavier Africa Academy, or in short, Xavier Academy. What we've done with the Xavier Academy, initially the goal was to be able to capacitate ourselves. So we basically built several curriculums over time around how we can take somebody who has very low level of information, knowledge on something that we need in the business, and then we're able to rapidly train them and then bring them into the business. Because you can imagine that this is a very technical area. So over the years now, actually, due to Let's Brian Mabua, who's here in the audience, he's been advocating to say, look, let's take this thing that we're using as an internal tool and actually take it out there for everybody else to be able to benefit from this particular thing. Because at the end of the day, the worst case scenario is that we have thousands of people that have been trained on these skills, and we suddenly have a talent pool that we can be able to get talent from. Same thing now, we're also contributing at the end of the day to the overall to everybody else. So really, there's been a lot of discussion internally to be able to now take those materials and then make them open source for everybody else to be able to access them. And it's a project that's been that's being done internally. And at the same time, we're big on teaching. So we've had some very good boot camps with several high schools and primary schools here in Botswana. Every year around the June 16 time, we take our time to go and teach kids something. So for example, I don't believe in teaching kids theoretical things or teaching them coding that is useless. When we go to a place, we will teach a kid something that if tomorrow morning they wake up and they say they want to make income out of it, they can be able to make income. So for example, one of the key programs has been the chatbot program. So we've been going through schools around the country, and then we teach kids how to make low-code chatbots. So a chatbot that can be able to solve different types of problems. So we take them through a problem-solving paradigm as kids. After that, we help them through understanding how they can be able to spot a problem and conceptualize a solution. And then by the end of that boot camp, they actually have a chatbot that solves that particular problem that they currently have using low code. And from there, really, that kid is able to, you're opening up that kid to be able to innovate, to be able to tinker, to be able to try different things. And who knows, they could be the next company that can be able to really build something for the future.
Yeah, most definitely. And when you talk about AI, there's always the fear of the ethical side of it.
Yes.
Talk to me about that and how you've been able to navigate, the ethics.
That's a very big one, right?
Yeah.
It's a very, very big one. And it's a space that we've really, really been looking at. I mean, so I think for me, for a long time, I've never really been big on trying to put caps on innovation very quickly and very soon. I'm a very big believer in AI ethics in that particular field. But for a very long time, I must be honest, I really didn't care about that field. Until several years ago, I think about 3 years ago, somebody showed me how deepfake can be used using the technologies that we're building and thinking they're just, helping to solve problems. So for example, somebody can take Vision X and they can take Samantha and they can be able to pretend that they've kidnapped your kid.
Yeah.
And using Vision X, they can be able to try and generate an avatar that looks exactly like your kid just by collecting some pictures of your kid from social media. And then from there, using Samantha, they're able to make it sound like it's your kid who is talking. And they're able to extort you for money. Or, full kids. Or, there's quite a number of really big ethical issues. I mean, even deep fakes around potentially using these technologies to pretend like, the president had said something when they really haven't said something. So there's really a lot of work that has to be done in ethics and AI. Yeah. And I think we've done quite a bit of really good groundbreaking work around that. Number one, around when we collect data, for example, we do not collect any personal information and personal data.
Because that one is also a big one.
Yeah. We do not
all
use
these
that.
Companies, you have to sign all these things now.
Exactly.
Data.
There we go. So we do not use any personal information or personal data that is personally identifiable to any individual person. So when we're doing that, all the data that we use, we anonymize all the key data around ID numbers, names, and whatever, for us to be able to train on data that is not biased towards anybody, based on that. Number two, a very big part of it is outside of ethics, there's a very big bias that comes with AI. And that bias is, remember what I told you earlier on. AI systems, in essence, are built depending on the data set that you're holding.
Yes.
So, for example, we'd say the example of 100,000 cats, 100,000 dogs. If, for example, within the set of dogs that you have more bulldogs than you have maybe of Rottweilers. Is it the same thing? Is it two different things, right?
Yeah. Or maybe a poodle.
Yeah, poodle.
The difference is night and day.
Yeah, let's say, but I wanted something that's close.
Yeah, that's
pretty close. Yeah, slightly close. What will happen is that if you have more data of the bulldog than the other, what will happen is that that model will be more biased towards where your data was biased towards. And it will not identify on the other side very well enough. So that's why, for example, right now we're complaining online, when you go to Facebook and you look at Facebook translations, they really suck in our languages.
They're bad.
Largely because the data says that these people, that everybody is training on, are biased to the languages that they currently have and the information they currently have. Same thing again when it comes to image data. So all the key technologies that are being built today, there's a very big responsibility on us as industries to be able to make sure that the data that we are using is diverse enough to be able to adequately help everyone across our populations.
Yeah, I think there's also like, what do they call it? Fiduciary duty.
Yes.
There's that.
That's that, yeah. That's the responsibility.
Yeah.
It's right there,
Yeah. Talk to me about this because it's something that I watched a documentary on it, this product Amazon created, Alexa.
Yes, Alexa.
Alexa answers all your questions, plays music. But the thing is that when you're not using it, it's eavesdropping on all the conversations you're having. And there was like backlash in terms of, the ethics to it.
Yes.
Because it's listening to everything. If you're a married couple, it's listening to everything.
To your fights,
everything, the fights, whatever. And it's getting to know you so well. But it's when you bought it, you bought it for X, Y, and Z.
Yeah.
So talk to me about that.
Yeah, so that's, again, right, a lot of these things are always taken out of context when we look at them from the outside, right? So I will try and look at one of the most important things, right? The most important thing is that when you're building these kinds of things like Alexa, what you want is convenience more than anything else.
Yeah.
So you want to be able to say, whilst you're sleeping on your bed and you say, Alexa, do this for me.
Yeah.
How else is Alexa going to be able to hear you
if it's
unless
not always
she's listening and
listening
streaming throughout, right?
Yeah.
That's one. Number two, personalization, right? In order for you to personalize something and really help a customer the best way possible, you've got to understand them in as much depth as possible. But it's the same time, right? There's a line, that we must draw. And I think big tech has been starting to learn that, to say, look, man, you can't be on micro details. But that's how personalization is done. You can only personalize a service if you understand intimately who you're personalizing the service for. So again, right, we need to be able to strike a balance between the convenience and the customer experience of these services, the personalization of these services and sort of usefulness of them, and also the privacy concerns that we have.
Yeah.
We cannot have roving, mics, if I can say, in rooms and people's private areas that are always listening and taking the data to data center somewhere. It's simply not ethical, when we do it like that. But at the same time, creating and striking that balance, especially in a fast-moving industry like this, is incredibly difficult.
Yeah. The target is always moving.
It's always moving. Tomorrow morning, I could wake up in the morning and something has happened, and highly likely so.
Yeah.
Yeah.
Okay, talk to me then about, as we're talking about the target moving forward, what are we thinking? How should we think of AI in the next 4 or 5 years?
Yep.
5, 10 years? Where should we be thinking, even in the opportunities that we can start to embark on right now? Yeah.
So look, I think one of the other things that I'm going to come and address this one as respectfully as I can. Right? I'm just trying to not be disrespectful to people who are really putting in some of that important work. But the solution for this revolution, this work that's happening, is not to make everybody an engineer or a coder or an AI engineer or a data scientist. That's not the solution. Those are simply means to an end. The most important thing that kids must be taught in school today must be how to solve problems. Yes, sure, math does that pretty well, but not in a way as visible as what we see in computing. So kids need to be able to say, I've got problem X. How do I get down to breaking down this problem to its bare essentials? And how do I then figure out how to solve this problem by iteratively trying to build something that solves this problem? The technology and the means by which this kid uses to solve this problem doesn't really matter as much. But what matters the most is having a continent of problem solvers who are able to look at a problem and say, that is a problem over there. Here's how I'm breaking it down. Like that kid in Malawi who built that irrigation pipe, the irrigation to be able to water the plants in his village during a drought. He wasn't a machine learning engineer or a coder or an engineer or whatever, but he understood how to break down the problem and then try different things to tinker around to be able to solve the problem. And yes, right now, computing is the most scalable way to solve a problem, because when you solve it once, you can solve it for hundreds and thousands of people. But at the same time, the most important thing that everyone is missing is we need to teach kids how to solve a problem. Once we teach enough kids how to solve a problem, we are going to be untouchable as a continent from now.
So where did we miss it in terms of that? Where did we miss it in terms of the way we're teaching right now?
Yeah. Look, I'm not a very big... I don't know. I'm not an educational specialist. You know what I mean? But it doesn't really help that the person who gets the highest grades, especially like at a high school and primary school level, is the person who can cramp the most. It doesn't help, right? Or somebody who is more naturally intelligent than somebody else. You can't say that a kid who's getting an E in a particular subject and one that's getting an A star in another subject, you can't use that as an indicator for the amount of impact and the amount of problem solving they're going to be able to do across the world. So if we're able to move our grading systems and our teaching systems into more problem solving based ways to say, look, there's a problem over there. Here are the resources that you need to be able to try and solve that problem. Go and try and reason around how you can be able to solve that problem. Then I think we might be able to get somewhere. But how can we do that? I don't know.
Thank you guys for watching this episode. We really hope you enjoyed it and learned something new. Deep Dive is dedicated to bringing you the most comprehensive and engaging information about business, personal finance, and personal development. Make sure to hit that subscribe button to stay updated with all our latest content. If you like this video, give it a like to show your support and help us reach a wider audience. And don't forget to share this video with your friends and your family who may be interested. Sharing helps us grow our community and connect with like-minded individuals. Leave a comment below and give us your biggest takeaway on this episode. If you're interested in being a part of our live studio audiences, make sure to register for the next show. Can't make it to the show? No problem. Check out our Patreon page to watch the full episode and get exclusive access to more great content. Thank you for watching, and I'll see you in the next episode of The Deep Dive.